Good morning, ladies and gentlemen. My name is Che-laeh and my partner is Sophia Singh-Kachari. Today we are going to present our project, Publication of Copper Metal Organic Framework Immobilized on a cellulose metric for Intelligent Packaging and Real-Time Seafood Spoilage Detection. The spoilage of food is a process caused by microorganisms such as bacteria that break down protein in the food, which produce compounds known as total volatile basic nitrogen compounds such as ammonia. These compounds are responsible for unpleasant odor and reduce the quality of seafood. The accumulation of this gas indicates the growth of harmful microorganisms. Therefore, accurately and real-time monitoring of this gas is essential for quality control in the seafood industry for ensuring food safety.
What is copper metal organic framework? Copper MOF or copper metal organic framework are a type of material made by combining metal ion with organic molecules to form a three-dimensional structure with many small pores, providing a high surface area for good interaction with gas molecules. In this study, we focus on copper MOF, which uses copper as an active site that is sensitive to seafood spoilage. As shown in the figure 1, copper MOF are synthesized from the reaction between copper 2 ion with BTC linker leads to cubic crystal structure.
Based on this problem, this study aimed to develop a freshness indicator using copper MOF immobilized on cellulose metric that is easy to use and allow visual detection with the naked eye. For our objective, to synthesize and characterize copper MOF, evaluate their sensitivity, selectivity, and apply them as a chromatic indicator for real-time intelligent packaging. For the first methodology, copper MOF was synthesized using copper nitrate and H3BTC in a DMF and ethanol in 3:1 ratio. The mixture was stirred and refluxed at 60 degrees Celsius for 10 hours to obtain blue copper MOF powder. Next, copper MOF powder was characterization for study their property using SEM, FTIR, and XRD.
This SEM image shows the morphology of characteristic of copper MOF. The crystal exhibit a well-defined octahedral shape with sharp edges. The FTIR spectrum shows the peaks at 487 per centimeter correspond to copper and oxygen bond, which confirm the formation of copper MOF. The XRD pattern shows the several sharp peaks of 2 theta of 6.7, 9.5, 11.6, and 17.4 degrees, which is matched to the characteristic of HKUSC1.
Next, the preparation of copper MOF chromatic indicator. Copper MOF suspension was sprayed onto a cellulose metric. This process repeats for 10 times to coating to obtain copper MOF chromatic indicator.
To testing the response of copper MOF indicator to different ammonia concentration. As ammonia concentration increased, the delta E value also increased and the appearance of indicator gradually changed from turquoise blue to light blue. This is because more ammonia molecules interact with the copper site, is changing the local coordination environment of copper. For testing response to different pH level, as pH level increased, the delta E value also increased and the appearance of indicator gradually changed from turquoise blue to gray and finally in brown at pH 14. This is because hydroxide ion interact with the copper site. It's changing the coordination environment around the metal center. During seafood spoilage, different volatile compounds such as alcohol, ketone, and acid were produced, so selectivity is important for accurate monitoring. The copper MOF indicator shows the small delta E value with this compound, which confirming the good selectivity toward ammonia.
To confirm its ability for real-time intelligent packaging, fresh shrimp 30 grams was placed in a petri dish with a copper MOF chromatic indicator on the lid. For the result at room temperature, the delta E of copper MOF chromatic indicator increased with storage time, starting from 0.0 at 0 hour. In the 4 to 6 hour, the indicator began to change the color from light blue to green blue, with the delta E increased from 4.8 to 20.5, indicating the start of shrimp spoilage. After that, the delta E continued to increase, reaching 84.5 at 24 hours, indicating more serious spoilage. For the result at 4 degrees Celsius temperature, the delta E of copper MOF chromatic indicator increased with storage time, starting from 0.0 at day 0. After 9 days, the indicator began to change color from 19.5 to 22.7, indicating the start of shrimp spoilage. After that, the delta E continued to increase, reaching 44.3 at 17 days, indicating more serious spoilage.
For the conclusion, first, copper MOF was successfully synthesized, confirming by SEM, FTIR, and XRD. Second, the copper MOF showed clear color change in response to ammonia, with delta E increasing as concentration increased. Third, the color response was more sensitive under alkaline condition. Fourth, copper MOF have good selectivity toward ammonia. And last, the copper MOF colorimetric indicator was successfully applied for real-time monitoring of shrimp spoilage.
This is our reference. Thank you for your all attention.